Okay, so now you know how to play the bug hunt game. You know how to download data. You know how to extract that data into a useful form, and you know how to plot a graph. But now we want to start playing with the variables and seeing what difference it makes. And this is where it could get really fun. You can change the environment. So you could ask a question about how does saturation change in different environments? Will it change faster? Does it change slower? In what direction does the hue change? Do I get different hues? I mean, surely I would expect that my hue should tend towards reds in the poppy field or reds and greens in the poppy field compared to if I switch my environment to a glacier. Now, what do you think will happen to the saturation if it's very colorful at 255 and grayish at 0? What do you think is going to happen to the saturation if I play the game on a glacier? What kinds of moths are going to survive? So I can change that. So I can change that as my research question. My independent variable is my environment. Let's say I keep the environment the same. It's a control variable. I can change the carrying capacity. So what's the maximum population size? If I have a big population size, how does that affect the rate that the moths evolve when hunted by the predator? So you could try different values of carrying capacity. You could try 5 different values. You can start with carrying capacity 15, 20, 25, 30, 35, 40, 45, 50. And there you're starting to get into the area of data collection that would be suitable for an internal assessment. Okay, so, but we could keep carrying capacity the same. Look, a control variable. Carrying capacity is the same, environment's the same. I can actually change how far away the offspring are produced. Now, when I eat a moth, so let's click go and talk about this. When I eat a moth, that actually generates the program to get one of the remaining moths to reproduce. So obviously, if I'm eating all the colorful moths, the moths that are remaining are reproducing and reproducing offspring that are similar to themselves. So what the algorithm does here, this offspring distance, is how far away is that new offspring from the parent. Look down here, you can see this little patch of orange moths. That's because the distance between the offspring and the parent is quite close. So they're forming a little clump, a little population, and I can just pick them all off. But what if they dispersed more? What if they were like seeds on the wind and they dispersed more? So we could change this, keeping everything else the same. We could change offspring distance to be 20. And then we can click Setup. Glacier again, Setup. Offspring distance 20. Now I can run the whole simulation again. Off I go. I can collect data on this and see whether that actually makes a difference. In what way does it make a difference? Does it make it harder for me to hunt? Does it make it easier for me to hunt? How does it change the brightness, saturation, the hue? How does it change the evolution of these moths? And think about this in the real world. How would these moths, if these moths were dispersing or not dispersing, what kinds of species in the environment send their offspring far away, and what kinds have their offspring living close? Stop that one. Okay, or I can keep the offspring distance the same, so it's my control variable, and I can change the rate of mutation. Now, if the mutations are very low, the offspring will look identical to the parents because there's not very much mutation. But if I put the mutation quite high, we'll actually have a green moth becoming a blue moth just because of a simple mutation in their color pigments. So the mutation rate could also play a role. So we can set that up with a high mutation rate now. I can click go and I can see what happens. And I'm only really going to be able to see what effect that this is having when I download that data and start looking at it, looking at my graphs and comparing it under different scenarios. So for now, before you start getting going on this, I mean, you can play with it. It would be great if you had a research question. So one thing you're going to change, whether it's mutation rate, distance from parent, carrying capacity, environment, what are you going to change? What data are you going to collect? Okay, so you've got hue, brightness, saturation over time. So you know you're going to collect that. But what variable are you going to change? And that becomes your research question. And from there, you can start being a predator again, collecting data, exporting the data, opening it, cleaning it up, getting some graphs, and then comparing the results under different scenarios.